Yeah, all right. Okay, so we're going to carry on with the idea of algebraic fractions, so which is where we started yesterday, and looking at simplifying them again. But we've got some different examples whereas yesterday the examples that we had, we used like single algebraic expressions. Now we're looking at expressions that might be in brackets. So here's an example. We've got the first example for you. I've got 5x plus 1 all over 20x plus 1. So I want you to have a look at that and to see what could I possibly cancel out to simplify that thing there, realizing that I've got a bracket in there. The 5 and the 20, all right, that seems obvious, doesn't it? Will the 5 and the 20 cancel out? Okay, well let's just do that and see what we've got left. So if I cancel the 5 and the 20 out, I think both of them divide by 4, and so I'm left with, no, both of them divide by 5, leaves me with 4. So an x plus 1 at the top here, and then I've got a 4 down the bottom, and I've got an x plus 1. So what about that x plus 1? Is there anything that I can do with that? That's a question for you. So is there anything I can do with that x plus 1?
Cancel.
Does it cancel, you think? What does it cancel with? The other x plus 1, isn't it? So notice that if I had, in the same way that if I've got a over a, that cancels to leave me with 1. If I have got a plus 1 over a plus 1, it's also equal to 1, isn't it? Because it's just the same thing. So anything divided by itself, as long as it's the same, will cancel out. So this will also cancel out. And that actually just leaves me with, now I need a 1 up here, leaves me with 1 quarter. Okay, so where this is different is that we're dealing with brackets. Now, because these two brackets are the same, there's no need to expand them out. Okay, so we wouldn't do that in this instance, maybe another time. So let's look at another example. So second example, and here I've got a plus b times a minus b and 2a plus b times a minus b. All right, so there's a lot of a's and b's in there, but we need to be really careful with what we cancel out. Okay, so a thing in a bracket is sort of a little unit by itself. Yeah, we can treat that as just one little thing by itself. There's no need to expand that out. In fact, if I expanded all of that out, it's not going to help. But we can see here that I've got an a minus b and an a minus b. So that is a little thing by itself, a little unit by itself, same as this one. So they will cancel, which leaves me with this, a plus b over 2a plus b. All right. Who thinks that I can cancel out that b over the b? You're wrong. Okay, we can't. And the reason we can't is look what we're doing. We are adding. Okay? So remember this. This is really important, and this is a common mistake that students make. They see b over b and they get all excited and think, hooray, I can cancel that out. And in fact, I could cancel out some of those a's, and all I'm left with is 1 over 2. But you'd be wrong. It only works if I've got ab and I've got 2ab because they are being multiplied. All right, so when things are multiplied, when they are factors, then we can cancel it out. This we can't. It just does not work. You can try it. You can substitute some numbers in there and see whether that works or not. And you'll find that it does not. So this cancels. Yep. But this will not cancel. All right, we can't cancel that any further. So in actual fact, we're finished. We can't do any more with that problem there as well. So just note carefully, I'll write it down for you as well, is that, all right, we cannot cancel out the b's. All right? All right. Only, how do you spell only? It's got an L on it somewhere. Yeah, that's right, isn't it? No, it's just, that wasn't looking nice. So only if they are factors. And that's the key to it. If they are factors, if something's multiplied by something else, then we can cancel that out. And that's why we can get away with this. This little unit is multiplied by 5. This bracket is multiplied by 20. So when we've got something multiplied, we can cancel it out, but not, okay, when there are factors, in other words, multiplication, but not addition or subtraction. Let's look at a third example. Okay, so this is, we're finished now, finished. 3. Right, 2a plus 2b, a plus b. Again, if we're to simplify that, you can see that, you know, we might be tempted to think, oh, well, the a's cancel out, the b's cancel out, therefore the answer's 4. Okay, but again, that's not right because we are adding, we're not multiplying. So, but we can cancel something out, but I need to do something first. Does anyone know what sort of thing do I need to do first before I can cancel something out? Yes, miss, you got your hide in your face, yes.
Factorise it?
Yeah, factorise, all right. So we're going to factorise that in this way. All right, taking a factor of 2 out, and now look what I've got. I've got an a plus b and an a plus b. You don't have to, but sometimes putting a bracket around that just helps you to see it, okay? So we can see there I've got an a plus b over an a plus b. Because that's a whole thing by itself, then what I'm left with is 2. Done. Look at another example. So 4. Yeah? So there we go. 5x plus 10y all over x plus 2y. All right. Can I factorise that top line? Yes, I can. All right, and I should. I can take a factor of 5 out of that top line. So if I do that and take a factor of, I take a factor of 5 out, that leaves me x plus 2y over x plus 2y. Look at that. You can see, I get a different coloured pen to make it more exciting for you. We can see that x plus 2y cancels with that x plus 2y. And what am I left with? 5. All right, and so that's all cancelled out, and that's much simpler than what we had before. So we'll keep going. So, and these next few examples are just going to be examples again of factorising and then simplifying. So if we want a little instruction here, this is what we've done. We're going to factorise, which we've done here, then simplify. And look what we've done here as well. We're going to factorise first, and once I've factorised, the simplification is done. We're just left with that 5. Factorise out and then cancel out that x plus 2y. The next example is similar. I've got x squared all over x minus x cubed. So that top line doesn't really factorise particularly well or in a useful way, but I can factorise the bottom line, So it gives me x squared, and I can take a factor of x out, which leaves me 1 minus x squared. And here now, hopefully you can see that I can take a factor of x out of both of those. So this x disappears, I'm left with 1 at the top, and therefore this thing simplifies to x over 1 minus x squared. And again, that's as far as I can go, so don't be tempted and think, oh look, we can't write because it's minus. As soon as I'm adding or subtracting, we can't do it, all right? So we have to leave that alone. We're finished with that one. That's as far as we can factorise that through. A couple more examples, all right? Example 6. X squared plus 6x plus something else plus 5, that's nice. And I've got x squared plus 4x, that's a 4, come on, plus 3. bit trickier. Can I factorise either the numerator or the denominator? Okay, so who thinks yes, I can factorise either of those? Who thinks I can factorise both? Well done. You've been taught well. So let's do that then. Let's factorise that top line, and I think I'm going to get an x plus 5 and an x plus 1, and here I might get an x plus 1 and an x plus 3. Okay, we've done that, haven't we? We've done that factorising. So you should recognise these, both of these as quadratics. Okay, you've got powers of 2, and we can factorise those with those 2 brackets. So I've factorised it, but is there something there that we can cancel out? There is, right? Okay, you can see there the x plus 1, so that x plus 1 cancels with that one. And remember, it doesn't matter which way around you write those, so the fact that that x plus 1's on the right, this x plus 1's on the left, it doesn't matter, okay? It still cancels, and this leaves me with x plus 5 over x plus 3. All right, who thinks we can factorise that further? Who thinks we can't? Brilliant, okay, no we can't, all right, because we're adding and they are not factors up there, so we need to stop. Last one. X squared minus 25, x squared minus 5x. Right. Can I factorise either the top line or the bottom line of that fraction? Who thinks yes? All right, and we can. In fact, we can factorise both of those. So with the first one, if you look at this, you should recognise that as the difference of 2 squares. All right, write that down. Difference of 2 squares. And if I do that, that becomes x minus 5 times x plus 5. And then over here I can take a factor of x out. So this is still a quadratic. This is a quadratic too, but there's just not 2 little brackets like that. And I've got an x minus 5. Okay, just make sure you've understood how that has happened and how we've got those factors there. Interesting, we call it factorising. And remember what did I said? We can only cancel if they are factors. And so actually what we've got is, if you look at, just going back a bit, you keep looking at that as well. But look, that's a factor, that's a factor, that's a factor, that's a factor. So those things in brackets are factors. It's just that the bit in the middle is something else. But the whole thing there is a factor. Right? And because we could, if we wanted to, we could write times there. We don't. Remember in algebra, if we've got 2 things sitting next to each other, it automatically means multiplication. So we don't need to do that anymore. Hopefully you've been had long enough, and you can see there that we can cancel out that x minus 5 because we've factorised, and therefore I've got 2 factors that will cancel, x minus 5, and I'm left with x plus 5 over x, and we can't go any further because I've run out of factors to factorise, and we are